All right, so today we're talking about section 2.2, which is more on the graphing and plotting of our linear functions. So from lesson 2.1, we talked about that figure, right? And we were graphing the points to kind of visualize the trend versus the pyramid that they had. So now we're going to formally define this and talk about what this actually means. So the XY coordinate plane, also called the Cartesian coordinate system, is used to plot points and graph lines. We use this a lot in pre-calculus. You will talk a lot about this in pre-calc, and in calculus, you will talk a ton about the coordinate plane. The main motivation for our understanding of the coordinate plane is that we want to visualize mathematics and trends. That is the main motivation. So think about it in your perspective, right? Or in our everyday perspective. For example, for me, I like to use plotting when I am visualizing the grade distributions in my different classes that I am teaching. So for this class, I plotted everyone's grades on a graph and looked to see if there's any kind of trend between them. So that's kind of the same concept, is that we want to use these plots to help us visualize problems that we have. So this is the Cartesian coordinate plane. That's what we call this. It's just been called that for a long time. The person that invented it, I believe his last name was Cartez, I believe, if I'm remembering correctly. And so they created this plotting system so that it's easier to visualize. So there's a few different terminology that we're going to want to talk about with this plotting. The first thing is the axes. So notice that we have a grid, basically some graph paper, and then it's split into fourths where there is a center here, and then there's these lines. So whenever we're plotting stuff, we always put X here and Y here. That is the standard notation that we use, and it is widely accepted as that. We do not want to flip the two, just for sake of notation, sake of clarity. We want to make sure that we always put X here and Y there. Since X is going to be this direction with these arrows, this is going to be the X-axis. This line here is what we call as the X-axis. So if that's the X-axis, then this line here is going to be our Y-axis. And these, again, are just the starting points for our X and Y coordinate system. The center here, where they both intersect, is called the origin. Basically, where everything starts, right? That's indicating 0, 0 there. Now we want to talk about quadrants. We won't really use quadrants all that much in this course, but it is important for you to know for future courses that you will have to take. So this is quadrant 1, and we call this Q1. This is quadrant 2, and we usually use Roman numerals. This is quadrant 3, and this is quadrant 4. So it kind of works counterclockwise. That's just the way that it has been. So in our course, right, we've been dealing with equations in one variable so far. So we've had x equals 3 plus 2x, or we'll have 3x plus 4 minus x equals 6 plus x, something like that, right? We've had those. Now what we're introducing is that we're going to be writing everything as y equals some combination of x. 3x plus 1, y equals 3x minus 5, stuff like that. So we want to talk about the notation that we're using. So when we have these equations like x plus y equals 5, again, there's two variables that you're going on, two varying terms. We want to represent this equation as a graph on the xy coordinate plane. A graph is a way to show a picture, and it is a powerful tool in explaining and understanding mathematics. Like I said, it is a visualization of data points. All of these points that you're graphing are data points. Think of it as you're able to quantify and to formally define some type of a data pattern. And that's what this x plus y equals 5 is. Say that that's the growth rate of bacteria of some sort. Now, again, bacteria does not follow a trend like this, but let's hypothetically say that this x plus y equals 5 represents the x being your starting point for the bacteria and y being how many bacteria are growing, something like that. And this will give you how many, right? How many different combinations can we find? So if we plug in 0 for x, we get 0 plus y equals 5. Well, that's just indicating that y has to equal 5. If we plug in 1 for x, 1 plus y equals 5, we now have an equation that we solve for y. Minus 1, we get y equals 4. Plug in 4. What if we wanted to solve for an x term this time, given that y equals some value? So x plus 0 equals 5. Again, that's indicating that y is going to be 5. Okay, so these points are some values, right? So let's see. However, these are not all the solutions to the equation, right? They're not all the solutions, but they're some solutions. So let's plot them. So remember back from our 2.1 with the big figure, we want to indicate our x and the y. And with the last section, right, we kind of just started at 0. We didn't have this left side. But with equations, we can have negatives. So let's plot 0, 5. So 0, 5 is our first point we want to plot. So we go x. This is always x and y. That's what we have. And 0 is going to be here for x, and 5 is going to be here for y. So whenever we're plotting x and y, this is how we always denote them. And remember, that's the same as what we were doing last time, where we had our n, or the input, comma the output. All right, so now we want to use 1, 4. So this is 0, 5. So we want to graph 1, 4. So here's x equaling 1. Here's 4. We can plot that there. So this is, actually I don't want to move this, 0, 5. This is 1, 4. And now we want to graph 5, 0. So x is 5 here, y is 0 here. X always goes to left or right, y is always up or down. Now we want to connect these points. So I'm just going to connect them. And I usually like to draw lines off the plane to indicate the line. So that's the plot. That's what we have here. So that's what the equation x plus y equals 5 looks like. So when we're graphing stuff like this, there's infinite amount of solutions, right? It all lies along that line. So x goes left to right, and y travels up and down. Okay, perfect. So, example 1, we want to make an x and y values using the points to graph this linear equation. So, let's figure out some points we want to use. Whenever they're giving you an equation and they're asking you to find points, I always start with 0 for x. So, I'll start with 0. Plug in 0 here. That gives me y equals 2 times 0 minus 6. It gives me y equals 0 minus 6, negative 6. Perfect. Now, what if I wanted to use 0 for y? Let's do that. Let's plug it in. 0 equals 2x minus 6. I have to solve for x. Add my 6 over, add my 6. 2x equals 6. Just swapping sides. Divide by 2, divide by 2. X equals 3. Okay, cool. Let's graph one more just so that we're okay with this concept. Let's do x equals 4. So we'll plug in 4. So we get 2 times 4 minus 6. We get 8 minus 6 is 2. Okay, so now it should be clear to you why we wanted to study equations and solving equations. because we have been now we're using these solving equations in an application. So we want to be fast with them. So I want to plot this point here. So that's 0, -6. So x is going to be here. Y is going to be here. And so I get 0, -6 down here. Okay, now I want to plot 3. So this is going to be 0, -6. Now I want to plot 3, 0. So finding the 3 on the x line, that's here. And 0 is going to be here as well for y. Remember, y goes up or down. So that's going to be 3, 0. And now the last one I want to plot is 4, 2. So finding the 4 for my x and 2 for my y. So y is up. So I found 4 here. Up 2 gives me here. All right, so now I have to connect all of my lines. So that's 4, 2, all of my points. So connecting these two and connecting all of these, I get a line that looks like that. So where does this graph cross the y-axis? So here's the y-axis. Remember, we talked about that. And it wants to know where does it cross it. And this crosses it right at that -6 value. So at y equals -6, that's where it crosses. And so this is called the y-intercept, and the ordered pair will always be in the form 0, -6. So this is the intercept, and the other one will always be 0. Same thing with the x-axis. We want to find where it crosses, and we know that it crosses at x equals 3. So the ordered pair will always be of the form 3, 0. Perfect. So we want to do the same idea with these two examples. We want to find the x and y intercepts. So what we have to do is make our little chart, x and y, and they're only asking for 2 points. We want to plug in 0 for x and 0 for y and solve for each one. So let's do it for the first one. Let's plug in 0. For x, so if I get -5 times 0 plus 2y equals 20, this cancels, so I'm left with 2y equals 20, which implies that y equals 10. Okay, now let's solve for plugging in 0 for y. So that's -5x plus 2 times 0 equals 20. I get -5x equals 20, which means x is -4. Okay, so now that we have this little chart, we can't just leave it like this. We have to actually determine what those intercepts are. So we say x-intercept, that is going to be when the y is 0. We want the value, so that's -4, 0. This one is our x-intercept, and this one is our y-intercept, where it crosses the y-axis. So y-intercept, 0, 10. Okay, so now we need to do the same idea for this one. We need to solve. Now this one was in a nice form because we could just plug in 0 and then we didn't really have to do much work. This one is going to be a little bit more work. So let's make our chart, x and y. So we know we have to plug in 0 for x and 0 for y. So we get y equals -8 times 0 plus 6. Well, that directly implies y is 6. This cancels. So there's 1. Now we need to plug in 0 for y. 0 equals -8x plus 6 minus the 6 minus the 6. I get -6 equals -8x. Divide by -8. That gives me an x equals 6 over 8. I don't want to leave it like that, so I'll get 3/4. Okay, so 3/4 will go here. We're going to want to leave everything in fractions for when we're dealing with graphing. So my x-intercept is going to be that 0, it's going to be 3/4, 0. That's my x-intercept, and my y-intercept is going to be the 0, 6. Okay, So some final definitions, and then I think it's just mixed practice from there. So some final definitions that we have are going to be, we have an equation written in the form ax plus by equals c is called the standard form of an equation. So the original equation that we had, that x plus y equals 5, is a standard equation where a equals 1, b equals 1, and c equals 5. Standard form. An equation written in slope form, y equals mx plus b, is called slope-intercept form of an equation where m is the slope, steepness of the line / how fast the line is growing, and b is the y coordinate of the y-intercept. For example, this equation, the slope is 2 and b is -6. That is it. That is how we find those information. So if we want to rewrite this in slope-intercept form, we have to rewrite. So we have y equals something, right? That's our slope-intercept form, is y equals mx plus b. We want to identify the slope and y-intercept. So we get y equals mx plus b. So we have x plus y equals 5. Mx, not 1, b. So we are going to move this x over. So we get y equals 5 minus x. Now this is not quite written in the form though. We need the x term first. So y equals -x plus 5. That is slope-intercept form. So if we want to peel off the slope, m equals -1. mb equals 5. Therefore, the intercept for y-intercept, is going to be 0, 5. You always plug in 0 there, and it's b. So the y-intercept is always 0, b. All right, we want to make a table of x and y values and use the points to graph this linear equation. So this is a standard form. Well, now it depends on exactly, whose opinion it is, how many points determine a line, because I know a lot of teachers are different, but for my opinion, by geometry, Euclid's elements, 2 points do determine a line. Therefore, you only need 2 points to graph a line. So if we plug in 0 for both of these, we'll get our 2 points, and then we can graph the line. So plugging in 0 for 2, or for x, we get 2 times 0 plus 3y equals 12. This is just 3y equals 12, which then indicates y equals 4. Okay? The next thing we want to plug in is 0 for y, so we get 2 times x, so 2x plus 3 times 0 equals 12. That indicates 2x equals 12, x equals 6. Perfect, 6, 0. We can plot these points and then draw the line. 0, 4 is going to give me 0, 4, that's here. And 6, 0 is going to be over here. Okay, that is it. And so I'm going to just connect these 2 points with a line. And my line is not completely straight, but it's okay. Again, with graphing stuff like this, you can only get it so perfect. You need calculus to perfectly graph everything. All right, rewrite this in slope-intercept form and identify the slope and y-intercept. So again, this is kind of like rewriting equations, solving. So we have to solve for y. So we have 2x plus 3y equals 12. Goal, y equals mx plus b, where m and b are numbers. Okay, so let's move the 2x over. So we get 3y equals 12 minus 2x. Cool. I'm going to rewrite this as 3y equals -2x plus 12. Cool, again. I have to divide by 3 on both sides. Y equals -2x plus 12 over 3. That's not quite our form that we were looking for. But what we can do is when we have fractions like this with an addition on the top, we can split them. So this turns into -2x over 3 plus 12 over 3. We're going to want to be comfortable with this idea of splitting fractions. So if you have a plus b over c, this is a over c plus b over c formula. Okay, now the last thing we want to do is simplify. I don't like to write it like this. I want to write it as 2/3 x, which we can do because x was in the numerator, plus, what's 12 divided by 3? 4. That is our final answer. So m is negative 2/3, and intercept, y-intercept, is 0, 4. b equals 4. Okay, so last thing, just some mixed practice to kind of get get comfortable with graphing. We want to write this in slope-intercept form. So we have 3x minus y equals 5. I want to move the y over to the other side just so that I can get y positive. So 3x equals 5 plus y. I want to subtract the 5 over and switch sides. So this immediately implies y equals 3x minus 5. Okay, that's what we want. Determine the x and y intercepts of these problems. Well, this is perfect because this is already in intercept form for us, right? So first thing, the y-intercept will be really easy. So y-int will give us 0, 4. Now we have to just solve for 0, x-intercept, something, 0. So 0 equals negative 1/2 x plus 4. Let's solve. I get negative 1/2 x equals negative 4. X is going to give me 8. Okay, again, you want to be really fast at solving these equations at this point. All right, this one's a little tricky. Y equals negative 2, intercept. This is technically y equals mx plus b, right? Where b equals negative 2, but m equals 0, slope of 0. Okay, so we want to have there is no x-intercept. There is no x-intercept because what this line is just a negative 2 horizontal line. So the y-intercept is going to be the same thing, 0, negative 2. Yeah, that's going to be it for the intercept that we're going to have. Okay, so negative 2 for y, 0. Okay. Next thing that we are going to want to look at is graphing the rest of these. Let me just, yeah, so there's no x-intercept because if we think about this, what this is here is going to be, yep, here's our graph. Here is y equals negative 2. So it's going to hit here, it's 0, negative 2. Perfect. Okay, so graph the linear equation by creating a table of values and or using intercepts, whatever your choice is. For this one, we're going to create an x and y chart. I'm going to plug in 0 for x, and I'm also going to plug in 1 for x. For some equations, it's faster to use just random points you pick. Other ones, it's easier to use their intercepts. It depends on what you want to do. So if I plug in 0, I'm going to get negative 1. And again, this is where our mental math is going to come in. We want to do some of it in our head. 1, I'm going to get 0. And look at that. That gave us both of our intercepts. So let's do 0, negative 1. It's going to be here. And 1, 0 is going to be here. So this is going to be our line we're interested in. Very tiny little line, but that's it. Okay, next one. Y equals negative 5 over 4, x minus 4. So here's our x and y. Whenever you have fractions, you always want to start with plugging in 0 for x. because that'll clear the fraction, right? Negative 5 over 4 times 0 is going to give me just negative 4 at the end. That clears the 0. The next thing is we're going to need to figure out another kind of another point that's going to clear the fraction, because I don't like to graph fractions. So I'm going to plug in negative 4 for x. If I plug that in, not only does it clear the negative, right? So negative 5 over 4 times negative 4 minus 4, y equals, we're solving for y. These are going to cancel, but that negative is also going to cancel. So I just get 5 minus 4. It's just going to give me 1. So 0, negative 4 is down here. And negative 4, 1 is going to be over here. So now I can graph this line like this. Okay, perfect. So there's our other line. We have this one, x plus 5y equals negative 10. So let's create our x and y table. So let's plug in 0 for x and 0 for y. Since this isn't standard form, it's easier to find the intercepts when it's like that. Because when you plug in 0 for x, you can cover the x with your finger and look. So imagine this is gone. Now you just have 5y equals negative 10. You can solve that in your head, right? Negative 2. Now, if I plug in 0 for y, this is going to go away, and I get x equals negative 10. That's why it's easier when you see something in standard form to plug in the intercepts and find them first. So plotting 0, negative 2 is going to be here, and negative 10, 0 over here. So I get something like this over this way. Okay, perfect. So that's our other line. Now we have x equals 5. Whenever we see these are going to be vertical lines. Since x equaling 5 is here, right? Whenever we see that, it's literally just indicating this line here. That is it. We don't have to make a table of values. We don't have to do anything. This is a vertical line. And so the last thing I want to talk about is the 3 different kinds of lines we're going to encounter. 3 kinds of lines. Number 1, standard lines that cross both axes. So this is, again, just going to be our normal lines. These are just going to be our normal lines that we've been dealing with in standard form. And we can have both x and y in them. Examples: 5x plus 2y equals 10, x minus y equals 5, y equals 6x plus 3, stuff like this. Those are the examples we have. 2, horizontal lines. These are lines that are fixed. They don't really change at all. So they are going to have y equals some number. Y equals a. So only crosses one axis, the y1. They're going to be in the form y equals some number. So examples: y equals negative 2, y equals 6 thirds, or 6 eighths, tenths, y equals 7 over 5, stuff like this. Y equals negative 34. They're all examples of horizontal lines, and they look like this. Their slope is 0. And the last kind of line is a vertical line, where it only crosses one axis, which is the x1. So examples, so it's going to be in the form x equals a, where a is some number. So we have x equals 5, x equals 7 over 10, x equals negative 2/3, and x equals negative 10. It looks like this. It goes up or down. Slope, undefined. So these are our three kinds of lines, right? This is y equals, this is ax plus b, y equals c, slope equals m, right, for mx plus b, right? We have all of that stuff. Some of these ones either have a slope of 0 or they're undefined for these types of lines. So those are all the kinds of lines that we're going to encounter this semester. In the linear equation setting, and then we'll see other kinds of things that come up later on. But for now, practice the problem set and try to review this lesson as well.